Hi everyone, and welcome to Book Days. I am so excited. Today's adventure has brought us to the McDonald Observatory in Fort Davis, Texas. And what better place to bring Goodnight Moon to life than one of the most premier astronomy centers in the state and in the world. Are you ready? I'm so excited to share with you the world of astronomy. Today's book, Goodnight Moon, is written by Margaret Wise Brown, illustrated by Clement Hearn. Do you say goodnight before you go to bed? Well, in this book, our famous bunny says goodnight to different objects and creatures in his great green room. And as his light dims, the big moon rises into the night sky. Find this book at your local library or wherever books are sold. And now I am so excited to give you the grand tour of the incredible McDonald Observatory and learn about the moon and night skies from the best experts in the field. Are you ready? Let's go. Everyone, I am so excited. Our adventure today has taken us to Fort Davis, Texas, to the amazing McDonald Observatory. And I am here with none other than astronomer Dr. Ia Lozada. Thank you so much for being here today.
You're very welcome.
As we start out, can you just tell us how long that you've been working here at this amazing telescope, the Harlan J. Smith Telescope?
I'm quite new here, so I have been working here only 3 months. But I have worked in a number of other telescopes before, so I have some experience on working in telescopes.
And you mentioned that you're from Spain.
Yeah.
What other telescopes have you worked on?
So I am from Canary Islands, and so I have worked in a number of telescopes in the Canary Islands. For instance, the Nordic Optical Telescopes that is in La Palma, and the telescopes that are in Tenerife.
That is so interesting. That's so awesome. And can you describe for our viewers, what does your daily routine look like as an astronomer?
So I am an astronomer that helps other astronomers to do their job. So part of my job is to do science, but the big part of my job is helping them. For instance, developing documentation, training them, helping them when they come here and tell them things that range from safety, please don't hurt yourself, to how to manage the telescope, how to use the instrument, or any other thing that they may need help with.
That's so interesting. Sometimes we think of certain careers like astronomers as you just look at stars all day, but it's so much more than that.
Yeah.
And why did you want to be an astronomer? What led you to be an astronomer?
When I was a kid, I really liked to know how things work, to the dismay of my mother that keep on giving me toys that I will, open up to know how they look inside, to never be able to mount them again. So I always wanted to know how things work, and this attracted me to physics. So I am one of these persons that I always knew what I wanted to be.
Wow.
And also I'm very lucky because I'm from Canary Islands. So we have an amazing sky. So I grew up seeing this that we see here at night.
Yes.
And wondering, where do we come from? How does that work? Why we have sun in the morning and then at night we have stars. So it was just a curious kid, I guess.
That's so awesome. I love hearing people's stories of how they got to where they are. And according to our book, we're learning about Goodnight Moon, one of the most famous children's books of all times. You were talking earlier about the different types of telescopes and looking at the moon. So would this be the best telescope to look at the moon?
Not at all, because the moon is too bright and this telescope is too big to look at the moon. So it's way better to look from a small telescope. But this telescope was very, very important for the Apollo missions to the moon.
Wow.
Because it had a laser, and they were able to measure accurately the distance from the Earth to the moon, how this changes with time. So it was very, very important to the Apollo missions.
Wow. So it's very interesting to me. I never knew, I always thought in the astronomy world, bigger is better, right? This telescope is so big and massive, and it just like, you just want to look at something through it. But really, to look at a big picture, like a smaller telescope is better. Is that right?
So the smaller the telescope is, the more field you can be.
See more.
And the bigger the telescope, the smaller you see.
That's so interesting.
So you need to combine all telescopes to be able to do your research.
So how far can you see with a telescope like this?
You can see very far, but the question is how much accuracy. You know, the farther you look, the less accuracy you have.
Yes.
So we can observe galaxies from here that are really far away, but we will not have the same accuracy as we will with a bigger telescope, for instance.
Interesting. And so what is your schedule like as an astronomer? Do you like sleep in the day? Do you work every night? How does that work?
In my case, since I help astronomers, normally I have a day schedule.
Okay.
But on the first night of the observer, I normally in the afternoon help them training or answering questions, and then I'm there for them at the beginning of the night. And it depends a bit on how it goes.
Okay.
And if they have any problem, they will call me or the engineer team, and we will help at any time.
Sure.
So like kind of the medical doctors.
Yes.
We are
You're
on
call.
Yeah.
I love it.
And sometimes I observe for myself or
Yes.
others, and then I do have night schedules.
So what advice would you give any children interested in astronomy as a career?
First of all, to get a telescope, a small one, and to look through them. And
That's
then
awesome.
be curious
So
about
simple.
everything that's around us.
I love that. A curious mind can take you a lot of places. Thank you so much for being here today. This has
You're
been
welcome.
so wonderful.
You're
Really
welcome.
appreciate it. So one of the other most beautiful telescopes at the McDonald Observatory is the Otto Struve telescope that we have come to right now. And I'm joined now by Coyne Gibson, the research engineer and associate scientist here on the facility. Thank you so much for being here, Coyne. And can you just explain, what does your job look like? You support the astronomers. How do your two jobs interlink?
The best way to think about what we do is we are customer service for scientists.
I love it.
That's our principal role here. All of the science operations, which include the operations and maintenance of the telescopes, the computational infrastructure, communications infrastructure that's used for science, my team supports all of that. If it breaks, we fix it. If it needs to be upgraded, we upgrade it. If people need to learn how to use it to get their science done, we train them to use our equipment to get their science. We provide overnight support, so we are a full customer service operation for the scientists.
Wow. And this is the oldest telescope on the property, is that correct?
That's correct.
And why is this one your favorite?
This was built in an era before computers. It was designed and implemented by smart people and craftsmen from raw brain power. It was built to last a century. It's now in its 83rd year of science and still going strong. And our goal is to bring this telescope to reach that century of science milestone.
So as an engineer, you probably could have picked any field. Why was astronomy the field that you chose?
This is the best job that you can get on planet Earth. It blends every skill, both academically and professionally, that I've ever had into one job, and I learn something new every single day.
Wow, I love it. And you actually live here at the observatory. How do you like that? What is that like?
It's a beautiful place to live. It's a beautiful place to work. I work with brilliant people. I work with people who are very passionate about what they do. The life here, it's isolated, but it's very peaceful, and it's an extraordinarily beautiful place to live.
No doubt. It is breathtakingly gorgeous, the views from this high of elevation. And Coyne, what would you have to say to children who are thinking about becoming an engineer?
Work with an open mind. Engineering is a broad set of disciplines. It blends mathematics and science. It blends some amount of hands-on and craftsmanship. So it's good for exercising the mind.
Yes.
Lots of opportunity, and it's never boring.
So you never have the same day twice?
Pretty much never.
I love it.
Pretty much never.
So what would be some of the key things that are necessary for kids to learn now for a career later in engineering?
Attention to detail is certainly one aspect of engineering. Learning how to be systematic, learning critical thinking skills, learning how to do things in an orderly manner are incredibly important. Having strong math, physics background is important. Knowing how to talk to people, how to communicate well, how to write well. So those are all strengths that you need in engineering. Ideally, we're documentation driven. Those are living documents, so the ability to write and to communicate is incredibly important.
That's super interesting. I love that piece because sometimes I feel like the math piece of careers, you focus so much on like the mathematics and the physics, but the communication skills and the writing skills are also so important. This is fantastic. Thank you for showing us your favorite telescope and just another beautiful piece of this amazing observatory.
Happy to do it.
Down the mountain with Coyne to see one of the baby telescopes, one that Dr. Lozada was talking about earlier today. And so Coyne, what are the functions of a smaller telescope like this?
So this telescope has a very wide field of view. It's 46.5 arc-minutes square. So in other words, the field of view is large enough where you can see the entire moon in it as one example. It's an example of a survey telescope. It's optically very fast, so it can collect a lot of light in a very short amount of time. So combined with that fast optical system and wide field of view, it makes a good system for monitoring transient events like supernovae or comets. That's the most common use that we have for it here.
And you said that this is kind of like a remote telescope, that you don't have to be physically here to view things.
Right. In this case, about 99% of our use of this telescope is by a remote observer somewhere else in the world. So you don't physically have to come here to use this telescope.
That is fantastic. And how many smaller telescopes like this do you have here at the McDonald?
There are 16 research telescopes here at the facility, and most of those telescopes are smaller than 2 meters. This is a 0.8 meter or a 1 meter class system.
So as an engineer, Coyne, how do you know what to do on all of these different telescopes?
So I study each of these systems because they're all unique. So I study the mechanical engineering, the electrical engineering, the control systems, the optics, the totality of the telescope, and how they work with the instrument payloads in order to understand how to maintain them and repair them. And probably the most important thing that we do is teach other scientists how to use them. So you have to know how to do both the science and the engineering to accomplish that. Wow,
I mean, that just blows my mind what you do, because look at all these wires. And this is just one of like the baby telescopes. It blows my mind that you know every single wire, and if something malfunctions, and this is just one telescope. That's, wow, it just goes to show what an important job an engineer, an astronomy engineer does at this facility. Fantastic, thank you so much for all you do. excited to be here at the Hobby Eberly Telescope here at the McDonald Observatory with none other than Dr. Stephen Janowicki, lead astronomer here at the McDonald. Thank you so much for being here today.
Yeah, thanks for visiting. I'm glad you can be here with us to see the biggest telescope in North America.
Wow.
We're lucky to be here with a 10-meter Hobby Eberly telescope. So you can just see the mirror up there, the curved shiny surface. If you see any things that look like curved lines, those are reflections. Everything in the telescope is pretty straight, and just the reflected light will make it curve up there. So,
wow.
and you can tell it's made of lots of little mirror segments as well. So when you build a telescope this big, you can't use a single mirror. You have to have lots of segments, separate segments of mirrors. And they're each about 3 feet across, and we have 91 separate little hexagons in there. And when the telescope is working at night and all focused, it all acts like one single mirror, collecting all the light from about 30 feet across. So the structure underneath here, all the blue sort of jungle gym.
That's a good way to describe it.
Yeah,
Wow,
that's all the supports that hold the mirror in the right shape. There's really fine motors and sensors on there that can adjust every mirror at high precision to keep it all in focus and lined up. But it's also fun to think that some of our team members have to crawl through there sometimes to fix things and correct some of the wires. So there's little, so you can almost see the little channels and pathways that you could imagine climbing through. Some of our engineers will go into there to fix things. I don't have to do that. The astronomers, they don't trust us with that kind of technical stuff. But you're right, the mirror is the heart of the telescope. That is what's collecting the light, and it focuses the light way up at the top of the telescope to what we call our tracker. So normally on a telescope, the mirror tracks the sky. The whole telescope moves as the sky moves, and it observes. This telescope was built in a really unique way where the mirror doesn't move very much. We can spin it around in a circle, but it can't go up and down at all. It's a design limitation to cut down on the operating costs and the building costs.
Sure.
So this telescope, you can tell it almost touches the dome up there.
Yes.
It fills the dome up, but it never goes up and down, so it just barely fits right in the dome. So when we're observing at night, the mirror is not moving, our tracker is moving. So we point the mirror kind of in the general direction of our target, and then we move the top part of the telescope to intercept the reflection of the target in the mirror.
Wow.
So it's a complicated system, but it allows us to build a gigantic telescope for a much smaller cost than if it could move up and down, basically. It was a cost savings.
Wow. And so what type of specific research do you guys do at this telescope?
So this telescope is a generalist. This telescope can do anything.
Wow.
Our main theme is spectroscopy. So we take the light from astronomical sources and break it up into the rainbow of colors, and we measure how much light comes in at every color. But we could do that for planets, for stars, for galaxies, supernovas, nebulas, star-forming regions, asteroids, comets, whatever. We do everything here.
That is so interesting.
This is an amazing, versatile telescope.
So can you describe how you do the research and how that comes into you, how you prioritize, the sky being what it is and the weather patterns being unpredictable?
Absolutely, that's the hardest part here.
Yes.
So there's a team of experts on site. There's 4 astronomers and 4 telescope operators who live here, and every night we're the ones operating this telescope. So astronomers from the different institutions that are members of the collaboration, they send us all of their observing requests, and they say, I need to look at this supernova, I need to look at this comet, I need to look at this galaxy, and we prioritize all of those based on the weather and where the moon is and all the conditions, and we choose what to observe with the telescope every night. And then it's sort of magic. All the data gets sent back to Austin as soon as they're observed. They get processed by a supercomputer, and at about 10 in the morning, all the astronomers who got data get an email that says, your data are ready, go download them. And so we've done all of the hard work for you, and it's like a full service telescope. They get reduced spectroscopy that they can look at in the morning and see, oh, that supernova was a type 1A, or that star doesn't have any lithium, or whatever their science question was. They get those results every morning from the telescope. So
that is so interesting.
It's an amazing system that makes astronomy really accessible and available to those researchers. And they're around the world. Most of our astronomers are in Austin, but some people are in Penn State in Pennsylvania, and then there's 2 German universities that are also partners here. So we're sending data all over the world every day from here. So.
That is so incredible. I love how astronomy is such an international
category.
The projects are so large
Yes.
that no one university or no one country can do it alone. To build something like this requires collaboration of many, many institutions.
So how did you get into this field?
I started by looking up at the sky. When I was a kid, my mom took me out a lot and we looked at the stars. And by the time I was in high school, we had an agreement that if you went outside for 10 minutes and saw more than 10 meteors, shooting stars, you had to wake the other one up. And you would be in trouble if you didn't. So if I got up at 2 a.m. for a meteor shower and I saw a certain number, she had a threshold. If I didn't wake her up, I'd be in trouble. So we always looked at the stars. I went to college and thought I wanted to be an engineer because that's very practical and very, financially stable, but not as interesting to me as astronomy was. And then switched to astronomy instead. But my favorite part has always been the observing. So I worked for a few years as a researcher, just solely on doing research, writing papers, analyzing data, and I didn't like that as much as actually being here with the telescope. So it's a lot of fun to get to drive the telescope and help people do their research and send data to all these different people who need that for their projects. So.
It's so awesome, just your passion for watching everything. I don't even want to say the stars because it's so much more than the stars.
Everything.
But that you get to do that particular niche. That is really interesting.
Yeah, there's a lot of jobs like that in astronomy. People think about just that one man sitting by himself thinking about the universe, but there's a whole team of people that support all of that project that goes on. The engineers here are amazing. The people that actually make this stuff work. I can study galaxies and that's pretty cool, but they can make this whole machine function. And when I say, oh, there's a problem with the thingamajig, someone can come in and fix it and we can keep doing the observations. So we have electronics engineers, mechanical engineers, software engineers, all sorts of different people that it takes to keep a facility like this running. Yeah.
And so you observe so much in the sky. How do you know exactly what to look for?
So telescope time, getting access to this telescope is really competitive. So by the time someone is telling us what to look for, they've already gone through like a careful approval process. So it's very competitive to get time. So by the time an astronomer has an idea, they say, I want to study galaxies, I want to measure this, I want to learn that, and that gets evaluated by a whole committee of people who try to find the best projects to do on the telescope. And then they send their observing requests to us along with the details, like here's what I'm looking for, it's going to be a galaxy, it should have these kind of things
coordinates
going on. We get finding charts, little X marks the spot, point the telescope here. And we do that. We probably observe between 10 and 20 objects every night with the telescope. Some are really short, maybe only a 10-minute exposure on that target, and some want like an hour or 2 hours of exposure. So that's where the telescope just sits and watches one thing for like an hour at a time. But yeah, everything is planned out and we know pretty much what to expect. If something goes wrong, then we're pretty good at figuring out what happened. So it doesn't happen very often, but that's sort of why they have astronomers here doing this job. So it's not just like push the button. It's like look at the observations and see, okay, was that good? Was that good enough? What else can we do better? So it's a lot of teamwork to help get the best observations for the science projects.
I love that.
Yeah, it's a great big community here of people.
That astronomy is definitely a team sport.
Yes, yes. It was maybe like 400 years ago. It was just like one person at a time. But these days it's massive. It's huge teams. We all share our data. We work together. We learn from each other, and we figure out the best ways to understand the universe with the biggest telescopes in the world.
Wow, this is so impressive.
If you want to come up.
Okay.
So this, I'm pretty sure this is the closest that anyone ever gets to a 10-meter telescope mirror. Normally these are pretty well protected and hard to access, but here we can just walk right up to it. So this is where the magic happens. Like all of the reflection, all of the light we capture from the sky gets reflected off of those mirror segments.
And what makes these mirrors? Are they kind of like the same material of like a mirror at your house?
No, so there's a couple of important differences. In your bathroom mirror, the shiny part is on the back of the glass. You can wipe the mirror and the shiny part doesn't come off.
Yes.
On here, we put the shiny part right on top because we don't want that light to go through any extra glass because it loses some of its light as it goes through the glass.
Sure.
So it's on top. And also these mirrors are made out of a very special glass that doesn't expand or contract when it gets hot or cold. So it's a really stable zero expansion glass. But otherwise, yeah, they're they're just glass. They're all polished, and then we have a facility downstairs that we can visit as well if you want. That every year we bring out each segment, take it out of the mirror, out of the telescope, strip off the aluminum with an acid wash, and then spray a fresh coat of aluminum onto it. And we recoat those because we do clean it 3 times a week, but you can see some of it still has a fair amount of dirt and debris. A lot of that is insect excrements that they deposit on the mirror.
Yeah, but that doesn't...
It has the effect of blocking a little bit of the light that would be reflected. We think it's like about a 2 or 3% effect, so it's pretty small. But we do constantly recoat the mirrors to keep them fresh and keep it, as good, as reflective as it can be. Because the light that we're looking at sometimes has traveled all the way across the universe to get to us, and we don't want it to hit a little dirty spot at the last minute. So, we work hard on the mirror.
So Stephen, with our book of the day, Goodnight Moon, can you talk a little bit about the moon in your research or lack thereof?
Yeah, so we love the moon because it makes it very bright at night to walk around, but it's so bright that it actually overwhelms some of the faint galaxies that we try to look at. So on nights when the moon is out, we're usually looking at stars.
The stars?
Instead, and we're usually looking at stars to find planets orbiting around those stars.
Interesting.
So we have a spectrograph downstairs. Actually, the light travels through this fiber optic cable all the way down to a spectrograph in the basement, and that lets us look for exoplanets orbiting around stars. So whenever the moon is out, we're looking for new planets around other stars. When the moon goes down, then we start to use these really big spectrographs in the black boxes up there, and those are helping us to study galaxies that are 2/3 of the way across the universe from us. The galaxies are very faint, and we have to look at them only when the moon is down. So
interesting.
Whether the moon is up or down changes a lot of what we do out here.
So would you say Goodnight Moon so you can study?
We would. I personally study galaxies. I personally really like galaxies. So when the moon is down, I'm happy. But when the moon is up, then we're looking at exoplanets and we're learning about stars, and there's a lot of exciting research there.
Sure.
So we do everything, just different things depending on if the moon is up or down.
Wow. So basically all your research revolves around kind of the moon.
It does. We schedule everything based on the moon. A friend of mine got married once, and they were like, we're going to schedule our wedding in 12 months. Can you make it? And I said, well, is it near a full moon or not? Because that changes our operating schedules. And they said, what? Who cares if it's near a full moon? But we schedule very carefully based on the moon phase. So.
And Stephen, what would you say to any children looking to be astronomers? What advice would you give them?
Yeah, well, study lots of math and science.
No doubt.
Keep looking up at the sky. And I think astronomy is all about asking interesting questions that are hard to answer but not quite impossible. So we build things like this to try to answer our questions. So if you have an interesting question, there's probably a way to answer it, and just keep trying to get that answer. Even if it seems impossible, because we've learned things about the universe that you would never think we could figure out. But with some smart people figuring things out, we've answered a lot of hard questions. So
that's amazing. Well, thank you so much for your time today. Oh my word, you got the inside scoop of the Hobby Eberly telescope. This up here by this mirror that I can almost touch, like nobody gets this. So this has been really special. Thank you so much for your time.
Yeah, thanks for visiting.
And be sure to subscribe so you don't miss any of our upcoming adventures. And we'll see you soon. Bye!
Want more book days? Well, the adventure has only begun. Check out these episodes and be sure to subscribe so you don't miss any of our upcoming adventures.